I want to explain this in detail, so this video is going to be a bit long, but after watching this video you are going to understand this type of question under circle geometry. Welcome back to my channel, welcome back to my page. First things first, remember that we have to apply this theorem in triangle that states that the exterior angle of a triangle, so let's say this is a triangle, okay, the external angle, this x, the external angle of a triangle is equal to the sum of the two opposite interior angles. So let's say this is 20 and this place is 30. What this theorem is saying is that this x, the external angle, is equal to 20 plus 3, which is 50 degrees. So the external angle is equal to the sum of the two opposite interior angles. Now, how does this concern what we are even doing here? When you look at this diagram now, you are going to see that PQR is a triangle, right? We have something like this. PQR is a triangle, all right? Yeah. So we have 40 here, we have 35 here. Okay, so you can see that there's an external angle here. So angle R is actually an external angle, angle PRS. So it means that this external angle should be 40 plus 35, right? Which is 75. So now we have here to be 75 degrees. But the question said we should find angle POS. POS. Anytime you are given something like this, you're expected to find the angle at the center. So POS, we are looking for this angle. Let's call it X. Now, I want you to remember a circle theorem that states that now this is a circle, right? And this is the center. If I should pick from here to here, part of this circle is called an arc. So this PQ from here to here, part of the circumference is an arc. Now, this theorem states that the angle which this arc subtends at the center of the circle, so this angle now, X, is equal to 2 times the angle it subtends at the circumference. Now, this is where the students get it wrong. I need you to see, how do I know that this PQ is subtending the angle at the circumference? Now, the circumference of the circle is all this circle, this line round the circle, distance around the circle. So the line must start from P, touch the circumference at any point, and stop at Q. It can even decide to start at P here, touch the circumference at any point, and stop at Q again. Okay, once the line starts from P, stops at Q, touching the circumference at a point, then it's still that particular arc that is subtending that angle at the circumference. Now, in order not to make this look so this thing, I'm going to remove this second one. So what this particular theorem is saying, that this angle now, that this PQ also subtends at the circumference, is 2 times the angle it subtends at here. Okay, so the angle, let's assume this is 75 degrees. What X will be is 2 times 75, so X will be 150 degrees. So if I should draw another line from P, touch the circumference, and stop at Q again, okay, it's still the same PQ. This angle will also be what? 75. It will be equal to this. All right, now that is it. Using this particular theorem, now you can see that this PS is an arc. This PS is an arc. Now you start from here, touch the center, and stop at S. So this X is actually subtended by PS at the center. And we also start from P, draw to the circumference, and drop at S, meaning that it's still this PS that is subtending an angle at the circumference. So if the angle at the circumference is 75, then the angle subtended by the same PS at the center should be 2 times 75, which is 150 degrees. So angle at the center is 150 degrees. And that is the answer to the question. Thank you so much for watching, and see you in my next video.